Welcome everybody to a new video. This video is about explaining the concept of lung development. Well, to make this a good story and in chronological order, we'll first start off with the gastrulation part. Gastrulation occurs around week 3. And what happens is that gastrulation essentially is the formation of a trilaminar disc from a bilaminar disc. So what we can see here is that we have this cell. And the cell will have a hypoblast, which is kind of the inner part, and an epiblast. And this is referred to as the inner cell mass, from which these two layers have differentiated. And what will occur is that from these two, from the epiblast and the hypoblast, we will form 3 germ layers, which are the endoderm, the mesoderm, and the ectoderm. So what will occur is that some cells of these epiblasts will differentiate and they will start to migrate towards the midline here. And what will happen then is that they will form the primitive streak. And this primitive streak allows for more migration of cells. So what occurs is that after having formed the primitive streak, we have more epiblast cells that start to migrate, and they will also migrate inside and towards the hypoblast, and there they will stop. So the epiblast cells that have migrated towards the hypoblast, this will form the endoderm, and the cells that have not moved, so have not migrated from the epiblast, they will form the ectoderm. And what we also have is that there are some cells located right here between the ectoderm and the endoderm, and these cells will then eventually become the mesoderm. So therefore we have formed three layers and 3 germ layers from essentially 2 initial layers that were the epiblast and the hypoblast. And this migration wave occurs from a caudal to cranial, so from your feet to your head, so more in a vertical line. So this was mainly very important to understand the next part, just to have a nice story. Well, okay, so then towards the lungs. Well, how do we develop the lungs? Well, we have these three germ layers, of course. They will all make up different parts of a human body. For example, in the ectoderm will form the brain and a process called neurulation. Then the mesoderm will differentiate into the notochord and somites and various other things. And then we have the endoderm, which will become various organs, and it will form the gut tube, it's called. So here we have the gut tube, and the gut tube can be divided into three sections, essentially the foregut, the midgut, and the hindgut. And these 3 sections will all differentiate and develop into different organs. What we can see here is that we here have the lung bud, which is part of the foregut, and from this part the lungs will start to develop. As you can see, eventually a little while later, you have the esophagus, which will connect to the stomach eventually, and we have here the trachea, with underlying here is a lung bud, and from this lung bud all the branching and elongation will happen. Around this part we have the lung mesenchyme, and there's always an interaction between the epithelial cells and the lung mesenchyme. As you can see here, how does the elongation part work? Well, like we can see here, we have a lung bud, and the lung bud will interact with the lung mesenchyme. So what we can see here is at the top of the lung bud we have some cells. I indicate this with a star to make sure that you can see that all of these cells have the same thing as this one indicated here. Is that these cells on top of the lung bud, they are NKX 2.1 positive. This means that they also express the FGF receptor 2. And what will occur is that within the lung mesenchyme, you have some factors such as TBX405 and retinoic acid, and these two factors will lead to FGF10 being present. And this FGF10 same as with limb development, you will learn that FGF is a very important growth factor. And this FGF will then stimulate these cells on top of the lung bud to elongate. So by means of FGF, for example, when the lung bud was initially here, this FGF will lead that the lung bud will elongate longer and longer until there is a certain stop. Well, of course, like we know, the lungs, they are very branched. So not only elongation needs to occur, but also bifurcation, which is a kind of fancy word for the branching process. Well, how do we then branch? Well, here's the branching process. As we have the lung bud here, at a certain moment, the cells on the top of the lung bud will start to express BMP4 and sonic hedgehog, and these factors will halt the elongation process by means of downregulating the FGF10 here. And it does something else. The sonic hedgehog, which is also expressed on the top of the lung bud, will activate the mesenchymal cells, which are these cells here, to start producing TGF-beta. And this TGF-beta in itself will also halt FGF10, but will do another thing, which is very important for the branching process, which is what we can see here. Well, essentially what TGF-beta does is, like we just saw, that it also halts the FGF10 regulation, but it also leads to extracellular matrix being deposited right here, which forms a kind of cleft. And this cleft makes sure that no elongation can occur in this part, so that the cells will divide going either of one way, in which here these are the NKX 2.1 positive cells that can be elongated by means of FGF10, and this will allow for branching to occur. And this process occurs the whole way of lung development because, like we know, the lungs are very, very branched. And then lastly, we have some stages of lung development. There are some stages indeed. We have 5 stages in total, and in each stage, different parts of the lungs are made indeed. So the first stage is the embryonic stage, which is until week 4, from week 4 to about 7. And what happens here is that quite a lot is made already. We have so everything from the trachea up until the segmental bronchi or the tertiary bronchi is made, and so this includes the trachea, the primary bronchi, the secondary bronchi, and the tertiary bronchi, as you can see here in the field stage. So there's quite a lot that's being made in the first few weeks. Then the second stage is what we have is a pseudoglandular stage, which is from week 8 to 16, from week 8 to 16. And what is made here are the bronchioles all up until the terminal bronchioles. Until the terminal bronchioles. So this is essentially within the first 16 weeks we have made the conducting zone of the lungs. Then the third stage is the canalicular stage, which is from week 17 to week 26. And in this phase, the respiratory bronchioles are made. As you can see here, the canalicular stage, the respiratory bronchioles are made. Then we have the fourth stage is the saccular stage, which is from week 26 to birth. And in this stage, the alveolar ducts and the alveolar sacs are made. And then the last stage is the postnatal, or also the alveolar stage, which is from week 36 to early childhood. And this is the part in which alveoli are made, which happens until various years after birth. And what is an important thing to remember is that I'll highlight it in another color, is that in the saccular stage here, this is when surfactant is being first produced. So in the saccular stage, the surfactant is being produced, but like we saw in the previous video, is that during preterm birth, the alveolar epithelial cells type 2 are not matured enough to produce the amount of surfactant that is needed, and therefore reaching the postnatal alveolar stage is very important. to get a better idea of how this lung development works is that you don't need to you need to know proximity of the weeks, because the weeks can differ from time to time. Like here you can see, for example, I use 8 to 16 weeks, and then this picture use 7 to 70 weeks. So the weeks can differ by 1 to 2 weeks sometimes, but you need to know that in the stacular stage is very important, that in this part, in this phase, the surfactant is being produced. So this is the first time that the surfactant is being produced. Thank you for watching. Don't forget to leave a like and subscribe. And if you've got any questions, feel free to ask in the comments.